Air pollution caused by vehicle exhaust emissions has long been recognized as a threat to the quality of our environment. As service technicians, we play an important role in meeting this threat each time we service a vehicle equipped with emission controls. It's critical that you know how to service each system properly. All of the AMC Jeep emission control systems are explained in past training releases. These releases are Emission Controls Part 1, Emission Controls Part 2, and Fuel Feedback Systems. If you haven't studied these releases, be sure to do so. Theory is covered in the films, while service procedures are detailed in the reference books that accompany the films. In this film, we'll be focusing on the exhaust gas recirculation, or EGR system only. Because the EGR system still remains somewhat of a mystery to some technicians, we'll look at the system's theory. Then we'll discuss the engine performance symptoms that may indicate a faulty EGR system. After you've viewed the film, you should have a better understanding of the EGR system and its effect on overall engine efficiency. You can then utilize the pocket-sized reference book that accompanies this film. The book contains detailed diagnosis and repair procedures. There are 3 types of harmful pollutants emitted by vehicles that operate on a gasoline-air mixture. These are unburned hydrocarbons, carbon monoxide, and oxides of nitrogen, also referred to as NOx. The EGR system controls only one of the harmful pollutants, oxides of nitrogen. NOx gases are formed during the combustion process. The amount of NOx gases formed is directly proportional to the temperature of the combustion gases. So, the higher the temperature of the combustion gases, the higher the level of NOx gases formed. NOx gases are the only harmful emissions that can't be measured with your dealership's infrared exhaust gas analyzer. This equipment measures only hydrocarbon and carbon monoxide emissions. Very specialized equipment is required to gauge NOx emissions. You've probably heard technicians claim that they can adjust older vehicles which are not equipped with emission controls to comply with modern emission limitations. This is absolutely impossible to do unless specialized equipment is used to measure NOx emissions. As we've said, the combustion temperature and the level of NOx gases formed are directly related. Obviously, then, this formula is the key to controlling NOx emissions. Lower peak combustion temperatures result in lower NOx levels. Probably the single most important factor influencing combustion temperature is ignition timing. Therefore, it's absolutely essential that factory-specified timing settings are maintained on every vehicle you service. The air-fuel ratio also affects combustion temperature. As you know, combustion temperatures increase as the mixture is leaned out. This graph illustrates the relationship between the air-fuel ratio and NOx emissions. The yellow line represents the level of NOx gases formed at various air-fuel mixture ratios. As the air-fuel mixture is leaned out, the combustion temperature increase results in a higher level of NOx formation. At a 16:1 ratio, the level of NOx gases created peaks. Beyond that point, the level drops, but the engine will not run. Unfortunately, the relationship between carbon monoxide levels and the air-fuel ratio is quite different. As shown here, the carbon monoxide level drops as the mixture is leaned out. The level of carbon monoxide is at its lowest at a 16:1 ratio. Hydrocarbon levels also drop as the mixture is leaned out. You can see then that a desirable air-fuel ratio is one that offers a compromise, which is 14.7 to 1. And finally, the EGR system affects combustion temperatures. It does this by diluting the intake charge with a metered amount of inert exhaust gas. The exhaust gas enters the combustion chamber with the intake charge. The exhaust gas will not burn. Therefore, the peak temperature of the gases in the combustion chamber is kept lower. The principal component of the EGR system is the EGR valve. The valve shown here has an integral exhaust back pressure sensor. This valve is used on all Jeep vehicles as well as some AMC vehicles. Some AMC vehicles utilize this EGR valve, which does not incorporate an exhaust gas back pressure sensor. In past years, AMC and Jeep vehicles utilized an EGR valve with an external back pressure sensor. Because this configuration is out of date, we will make no further mention of it in this film. This illustration depicts the flow of exhaust gases in a 2.5-liter four-cylinder engine. Most of the exhaust gases exit directly through the exhaust manifold to the exhaust system when they leave the combustion chamber. The gases that are to be recirculated, however, are channeled into a crossover passage in the cylinder head. Under certain engine operating conditions, the EGR valve allows these exhaust gases to mix with the intake charge in the exhaust manifold. This entire mixture is then drawn into the cylinder. This illustration depicts the flow of exhaust gases in a 258 six-cylinder engine. Here, too, most of the gases exit directly through the exhaust manifold to the exhaust system. The gases that are to be recirculated are channeled through the EGR valve into the intake manifold. They are then mixed with the intake charge. The mixture is then drawn into the cylinder. This same flow takes place in V8s. It's important to keep in mind that exhaust gas recirculation doesn't take place until the engine is warmed to a calibrated level. Both of the EGR valves used on our vehicles operate on carburetor-ported vacuum. A coolant temperature override, or CTO switch, is positioned between the carburetor and the EGR valve. The switch's S port is connected to ported vacuum at the carburetor. The E port is connected to the EGR valve. The CTO switch prevents EGR from taking place until the engine is warmed to a calibrated level. The base of the CTO switch is immersed in engine coolant. When the coolant temperature is below a calibrated level, a spring holds a check ball in an opening within the switch. This check ball blocks vacuum to the EGR valve. When the engine warms, this action takes place. The wax power element is warmed and expands, forcing the check ball from its seat. Vacuum is now passed to the EGR valve. The CTO switch then assures that EGR doesn't occur until the first prerequisite, a warm engine, is met. This is a cutaway of the EGR valve that does not contain an integral back pressure sensor. The engine is still cold, so no vacuum is available to the valve. The spring tension holds the pintle in its seat. Therefore, the exhaust gases are blocked. When the engine warms, the CTO switch passes vacuum to the EGR valve. If the vacuum signal is strong enough, spring tension is overcome and the pintle is unseated. EGR now takes place. It's important to keep in mind that sufficient vacuum exists at cruise speeds only. Carburetor-ported vacuum is not strong enough to facilitate EGR at idle or wide-open throttle. The valve that contains an integral exhaust back pressure sensor imposes another prerequisite that must be met before EGR takes place. This second prerequisite is sufficient engine load. On vehicles equipped with this valve, the engine load must be enough to generate a calibrated exhaust back pressure in order for EGR to occur. This is a cutaway view of the valve with an integral exhaust gas back pressure sensor. The principal components are the vacuum port, power diaphragm, control diaphragm, pintle, and bleed valve. Here, the engine is warm, but the back pressure is low. The low pressure travels up the hollow pintle stem and pushes against the control diaphragm. The stronger opposing spring force holds the bleed valve open, so the vacuum bleeds to atmosphere. The pintle remains against its seat, blocking the exhaust gases. No EGR occurs. Now the engine load has increased, resulting in high exhaust back pressure. This pressure has overcome the spring's tension, and the control diaphragm has been forced up, blocking the bleed valve. Vacuum is now applied to the power diaphragm. If the vacuum signal is strong enough to overcome spring tension, the attached pintle is away from its seat. EGR now takes place. Remember that sufficient back pressure exists only at cruise speeds and full throttle conditions. There is not enough back pressure generated at idle speeds to facilitate EGR. This chart provides a visual description of the prerequisites that must be met before EGR can take place in engines equipped with EGR valves incorporating a back pressure sensor. At idle speeds, sufficient back pressure is not generated, nor is sufficient ported vacuum available. Therefore, EGR does not take place at idle speeds. At cruising speeds, sufficient back pressure is generated to facilitate EGR. There is sufficient vacuum available if the engine is warm. If both prerequisites are met, EGR can take place at cruising speeds. Under full throttle conditions, sufficient back pressure is generated. But because ported vacuum is not available, EGR cannot take place. There are several additional EGR system components that are used on various engines. Some AMC and Jeep vehicles feature this thermal vacuum switch, or TVS. This component, which is located in the air cleaner, controls the vacuum passage between the CTO switch and the EGR valve. The thermal vacuum switch imposes yet another prerequisite that must be met before EGR is allowed to take place. In systems equipped with this component, the air temperature within the air cleaner must reach a calibrated level before EGR occurs. This prerequisite helps the engine perform better when it's cold. This cutaway depicts the internal component of the TVS, the bimetal strip. Here, the air cleaner temperature is below a calibrated level. The bimetal strip is blocking off vacuum to the EGR valve. When the air cleaner temperature reaches the calibrated level, the bimetal strip moves away from the orifice, allowing vacuum to pass to the EGR valve. Some AMC and Jeep EGR systems utilize various delay valves. These valves modify the initial vacuum signal to the EGR valve by delaying the full vacuum force. This action allows a smooth activation of the EGR system. The delay valve is located between the EGR valve and its vacuum source. It's essential that the black side of the delay valve faces the EGR vacuum source. Be sure to keep this in mind when you're servicing an EGR system. A restrictor plate is also used with some engine configurations. The restrictor plate is sandwiched between two gaskets and installed between the EGR valve and intake manifold. These stainless steel plates are calibrated for specific engine applications. Every restrictor plate bears an identification number or letter. If you replace a restrictor plate, be sure the new plate bears the same identification as the old one. Here's another component you may find on some AMC and Jeep EGR systems, the vacuum signal dump valve. This component is also located between the EGR CTO switch and the EGR valve. The vacuum signal dump valve monitors intake manifold vacuum. When manifold vacuum drops to a calibrated level, as in a wide-open throttle situation, this component dumps the ported carburetor vacuum signal before it reaches the EGR valve. In order to properly service EGR systems, you must be able to recognize the engine performance symptoms of a faulty system. A system that isn't functioning properly can result in a rough idle condition, sag or hesitation, or detonation. Once you've recognized any of these symptoms, you must be able to relate them to their specific causes in order to correct the condition. A rough idle condition can result when carbon deposits build up on the EGR valve pintle and its seat. As we've said, the valve must be in its closed position at idle speeds. If the pintle can't seat because of carbon buildup, the valve remains partially open. This recirculation of gases at idle results in an uneven idle condition. Engine sag or hesitation can result when the EGR valve is opening when it should be closed. A faulty diaphragm or weak spring can cause the valve to open at idle, at full throttle, or when the engine is cold. EGR valves are not serviceable, so a faulty valve must be replaced. Detonation can result if the valve remains closed when it should be open at cruising speeds. Because the combustion temperatures are not being controlled by EGR, an overheating condition occurs. This condition is evidenced by detonation. The valve may remain in its closed position if a vacuum leak is present or the valve is defective. Detonation can also tip you off to a disconnected EGR valve. Because the cooler exhaust gases are not controlling combustion temperatures, an overheat condition results. There is a common misunderstanding among some motorists and technicians that a disconnected EGR valve improves performance. The truth is that not only is performance worse, but the resulting detonation can cause damage to valves, pistons, and cylinders. Also, the legal implications of EGR disconnection speak for themselves. Most technicians are aware of the federal laws that prohibit anyone from tampering with any factory-installed emission control device. Unfortunately, some forget that the technician involved, not the customer, pays any fines associated with the disconnection of emission control devices. And that's it. To test your understanding of the information we've covered, see if you can answer a few review questions. Number 1. EGR controls NOx emissions by controlling combustion temperatures. Is this statement true or false? Number 2. Both AMC Jeep EGR valves monitor exhaust back pressure. Is this statement true or false? Number 3. When an EGR valve remains closed when it should be open, the result may be A. detonation, or B, sag or hesitation? The answer to number 1 is true. Number 2 is false. As we've seen, only one valve features a back pressure sensor. Number 3 is A, detonation. When the inert exhaust gases aren't available to control combustion temperatures, overheating and detonation result. Equipped with EGR information we've covered, you should now be able to apply the diagnosis and correction procedures contained in the film reference book. You'll be glad to see that these procedures are not only effective, but they are also easy and quick to perform. We hope you utilize them. Because, remember, proper emission control maintenance is the biggest contribution we can make to the health of our environment.